Swayam Prabha. Digital India. Educated India.
Welcome back. So we got a new topic going for you today, nomenclature. Naming molecules, right? There are trillion, billions of molecules out there, and if you start naming them, John, Jacob, and Mary, we'd run out of names just to name all the molecules in a cup of soup. Okay, so because there's so many, thousands and thousands and thousands of possibilities for all of these non-metals making covalent bonding in different shapes and sizes and numbers. We got to have some kind of systematic way of naming them. So here's what we're going to do. We're going to have some rules, follow the rules, and name it. And every single time, you should be able to go from the name to a structure or from the structure to a name. That's our goal. And these are called IUPAC rules, International Union of Pure and Applied Chemists. And it's a wonder that they agreed on anything, but they did. And here it is. The name has three parts, a prefix, a parent, and a suffix. What does it mean? A parent, that's kind of the most important part of the chain, guys. If there's no parent, of course, there's no kid. So longest contiguous chain, you have to be able to write that parent without taking off your hand. It has to be a continuous line, and it's got to be the longest line possible. Second, number the parent chain to give the lowest number to the first substituent. For some reason, the firstborn is always very important, okay? So when you go along the chain and you meet a branch, that's called a substituent. For example, let's say you have a long chain of carbons, and then you have a branch. That's called a substituent here. You can have many, many branches here, 2 carbon, 3 carbon, 4 carbon, branch carbon, all kinds. As long as the parent chain is the longest one, everybody popping off of that is a kid. And so we have to name the kids and put them in the front and then name the parent, like Brian Johnson. So here you got to have the number the parent chain to give the lowest number to the first substituent. So here this is 2, here 1, 2, 3, 4. So you would go this way, 1, 2. That's what they say. Number the chain to assign the lowest number to substituents overall. So let's say we have the same thing over here and here, then you're going to number it to give the lowest numbers possible to the branches. Let's say you have 2 numbers the same, then you have to assign according to alphabetic priority. So let's say you have chlorine and bromine, so then you go according to alphabetic priority. So lowest numbers are important, alphabetic priority is important here, okay? So, and then each carbon is either part of the chain or part of the substituent. It cannot be part of the chain and part of the substituent, okay? So once you take the chain out, everything else is the substituent. You can't count a carbon twice, one for parent, one for substituent, okay? All right, so having gone that far, let's do a problem here. So over here, let's say this is a long chain, 1, 2, 3, 4, 5, 6. That's just going by the root name. Root name, 1 carbon is meth, 2 carbons eth. This is something you need to know. 3 carbons prop, 4 bute, 5 pent. Now it's more like your geometry, hexagon, pentagon, and so on. Hex is 6, hept is 7, oct is 8, 9 is non, 10 is dec, undecane, dodecane. That's something you got to know. So this is a simple 1, 2, 3, 4, 5, 6 hexane. So this is your parent, root, and your suffix is the main functional group. In this case, we really don't have any functional group. They're just basically alkanes. So this is ane. Let's say I decided to prop a substance. This one has a branch sprouting out like this. Then you have to go by the rules. So longest chain can be this or this. So over here, let's say you have a long chain and you have 1, 2, 3, 4, 5, 6. 2 has a methyl. How do you write it down? So a substituent name ends as an "-ile". So you have a 1 carbon meth. You just add an "-ile" to it, methyl. If alphabetize the substance, we don't have that hyphen between number and letter. So we have to say where it is. You can't say methylhexane because the methyl could be anywhere. And if you want to buy it out of, let's say, VW or Aldrich or someplace, they're going to ask you, what kind of hexane do you want, guys? 3-methyl, 2-methyl, what do you want? So we have to specify where it is, because 2-methyl and 3-methyl are going to be constitutional isomers. You got to say which isomer it is. 2-methyl. Right. Then no space between parent name or parent name and substituent. So don't put a space here. 2-methyl hexane. Prefix is telling you where and what the substituent is. Parent is the root name. That's in this case 6 carbon is the longest chain. And ane is your suffix, which is your functional group. In this case, it's actually a lack of functional group. When you have alkanes, there's really no functional groups. So it's just an alkane. Anything else, if you have a double bond alkene, alcohol, ketones, so many things that you can have. Let's do one that's a little bit more complicated. So you got 3 of these branches coming off. What's their longest chain? That's the important thing to first figure out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So all of these could be possible parents. So 1, 2, 3, 4, 5. So then what is going to be your prefix? That's going to be the substituents here. They are just 1 carbon, so it's methyl. You got to say where. So 2-methyl, there's another 2-methyl, there's another 4-methyl. That's going to make this name super long when we can do it in one shot and call them all out at the same time. So here what we do is if 2 or more substituents are present, use di, tri, tetra, penta. And don't use the di, tri, tetra, penta for alphabetizing. Don't use this, except this. Don't use those for alphabetizing. So here, in this case, there's only 1 type. We don't have to worry about it. So 2 has got a methyl, but it has got 2 methyl. So you got to say 2, 2. Otherwise, they'll only think there's only 1. And 4. And so there's 3 of them. Trimethyl. And that takes care of all of the kids. Now the mom and dad is just the longest chain, 5. 5 is pent. There's no functional group, so it's pentane. And I'm going to just write the pent here. There is no space between those if you're writing it on a line. Ane. Okay, well, here's 2 different chains popping off. So here, if I number this left to right, and try to number from the side where there are more branches, because it says lowest number to the substituents. And the first substituent should get the lowest one. So here we can do 2 things. You can go 1, 2, 3 and get to that junction, or 1, 2, 3 and get to the junction. Which one should we do? Well, follow the rules. It says here, number the parent chain to give the lowest number to the first substituent. So over here, when you're coming this way, 2 has got a methyl. When you're coming this way, 3 has got this branch. So when you're taking this, it's like taking a scenic route. You got plenty of time. You want to see as many things as possible. So don't go through here because you're going to miss this scenic vista point here. But if you go through here, you're going to hit this vista point and this vista point. You're going to see a lot more. So here you bought the tickets. Why do you want to rush through things and miss out on these lookout points? So each of this is like a lookout point. You want to go to as many as possible. That's what the rule says. So don't go this way. because you're only going to get one lookout point. Go this way, you're going to get 2 lookout points. You're going to see more. And then you're going to give it the lowest number possible, 4, 5, 6, 7, 8. So 2 has got 1 carbon, which is methyl. 3 has got 2 carbons, ethyl. So 2 methyl and 3 ethyl. Those are your side chains. And always get in the habit of putting a line between a number and a letter. Who do you mention first? So when you have names to alphabetize on the substituent, you have to alphabetize them according to the first letter of the substituent. 2 and 3. Over here, you're going to say 3 and then ethyl. So it's not by numbers, it's by letters purely. 3 ethyl, 2 methyl. Even though this is appearing before this, the rule is to alphabetize E before M. And the parent is octane. Octane. So here's another rule that we are going to apply. You're going this way or this way or this way. Those are the possibilities. If you go this way, you're going to not have the longest chain. If you go this way, that's going to be 1, 2, 3, 4, 5, 6. You've got to have the longest chain. That's the first rule. Find the longest chain. If that's wrong, everything else is wrong and you're wasting a lot of time. So 1, 2, 3, 4, 5, 6, 7 is longer than 1, 2, 3, 4, 5, 6. So you won't go this way. You'll go left to right. Then the next thing is, should you go this way to the junction or this way? Again, lookout points will be more here. So you would go this way. This is not part of the chain, this is a substituent. Next question, should we go left this number 1, 2 from here or number 1, 2 from here? Okay, that's the parent chain is this. We found the longest chain. Let's look at the rules. Number the parent chain to give the lowest number to the first substituent. So over here, 1, 2, 1, 2. Well, both are correct. If the numbers are the same in either direction, assign according to alphabetic priority, which means B before C. So bromo and halogens have the exact same priority as hydrocarbons. So let's say you have a bromo here and a methyl here. You don't give the hydrocarbon a preference. You go with the halogen because it's alphabetic priority. And what is this branching? Well, when you have a branch like that, it's 3 carbons. And it's so propyl, and then it's branching from that. So that's a isopropyl. So that's isopropyl. It's isopropyl. Now, for iso is an exception. I know you hate exceptions, but you can't get around it. It's in the rules. So here, iso has to be alphabetized. Include isobis, tris, tetrakis, pentakis, hexakis, my ass, and so on. All right. So you have to do the iso I for alphabetizing, and this is ethyl. All right, E. So then you put all the kids according to alphabetic priority here. So when you're calling names, you call Adam, then Ben, and then, so on in the family. So you've called them according to the first letter. Bromo, then chloro, then ethyl, then isopropyl. Then you just put the numbers and write it down. 2 bromo, and then let's say 1, 2, 3, 4, 5, 6, 7. 6 chloro, 5 ethyl, and then I don't have space, but if I had, I'd put a line and continue. 4 isopropyl, and then the parent, which is 6 heptane. So we're kind of applying these rules as we go. So over here, here's a long molecule, and we can number it this way and get bromo, or we can now go this way and get chloro. And first of all, let's see what the longest chain is here. So over here, if you do the longest chain here, 1, 2, 3, bromo, 4, 5, 6, 7. So every time you get to a junction, make sure that you go the longest route possible. So this junction, this is 2 carbons, this is 3 carbons. So you keep going this way. So there's 1, 2, 3. Even though you have lots of branches here, longest chain precedes the number of substituents. So then should we number it this way or this way? Let's look at it. 1, 2, here. If I go this way, it's going to be 1, 2, 3, and it says number the parent chain to give the lowest number to the first substituent. Doesn't matter that this is B and this is C. We still have to give the lowest number to this side, because the first lookout is coming sooner. So you want to get to the lookouts, and you want to get to the lookouts before lunchtime. So the sooner we can do, the more we can do at the beginning, the better, right? You're wide awake. So here, you don't want to have a long chain and hit the lookout like when you're going to sleep. 1, 2, 3, 4, 5, 6, 7, 8. So then we already decided we're going this way. And then after that, we just go in and write down the substituents according to alphabetic priority. So who's going to be called out first? Bromo, and what is this? This is like a chicken feet, okay? So you have 4 carbons, and it's a tertiary carbon that's attached here. So it's a tert butyl. Tert, and you have to put a hyphen. And these are methyls. So then methyl 3, 3, 4. Trimethyl. So trimethyl, but you don't put in line between di, tri, and so on. Only sec, tert, n, you put a line. So R before U, so they're both beginning with B, so bromo. So you're going to alphabetize by the second letter. So bromo before butyl. So you start with 6 bromo. Then it will be tert butyl. That you have to say where it is. It's on carbon number 4. 4 tert butyl, or you can say T butyl. They're both correct. You can shorten this to a T, but make sure you put the line. So after B is the C, 2-chloro. So again, as I said, numbers don't really matter when you're writing the order down. Only the first letter or the alphabetization matters. 2-chloro. And then you call out the methyls because they're M. That is going to be 3, comma, and then this also should go from lowest to highest. Trimethyl. You don't put a line after ti, di, and so on, but you do put a line after n, sec, tert. But do not include n, sec, tert for alphabetizing. So it's basically these letters C, and then not tree M. And then the parent is octane. If you get that far, then you are fine, octane. Now here's a cyclo compound or a cyclic compound. Here, your longest chain is a 6-carbon chain, but it's in a ring. So we have to say cyclo in front. Now the rules for this is a little bit different. Here, your numbering is entirely by alphabetic priority. Because it's a ring, you know, where do you start? There is no one side or another side to start from. You got to pick one point. So we pick the point that has a substituent that has the highest alphabetic priority. Over here, this is B, C, M. So obviously bromo, then chloro, then methyl. So lowest number to highest alphabetic priority. So here, this is going to be different from this. Here also you have bromo and chloro, but here you're going to go with the lowest number to the first substituent. Here, there is no first substituent here because there is no end. So you start with the alphabetic priority here. So 1 bromo, 3 chloro, and you don't have to put the 1. All other numbers you have to write down. If you put bromo, 3 chloro, it's understood the bromo is on 1. And then 4 methyl. And then it's 6 carbon is the longest chain, so it's cyclohexane. So cyclohexane. Cyclohexane. Let's look at this one. We have here a long chain, 1, 2, 3, 4, 5, 1, 2, 3, 4. So obviously we're going to go this way. 1, 2, 3, 4, 1, 2, 3, 4. Which one is better? So as we said, find the longest chain with maximum branches. You kind of paid your money out there to some Viator or some company. You want to see the maximum you can. You don't want people to just like kind of short circuit you and take you home. You want to explore everything. So if you go 1, 2, 3, 4, that's one possibility, or 1, 2, 3, 4, that's another possibility. So both these are the same number. So you have 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. However, this one has only 1, 2 branches. If you go this way, you'll have 1, 2, 3, 4 branches. So you take the one with the maximum number of branches. So we know this is going to be our parent then because it's got the most number of lookout points. The next question is, where do we start numbering? If I go this way, 2 bromo. If I go this way, 2 bromos. If the first number is the same, then assign the numbers to give the lowest numbers overall. So then we can decide on the first group here because they're the same. We got to look at the others. So this is 3. If I go left to right, it'll be 3, 3, 4, and 6 for the other groups. If I go right to left, it's going to be 3, 5, 6, 6. Because these two are the same, so that's not really going to change. Which one are you going to use? Left or right? So where do you start your journey? Are you going to start in Ethiopia and go down to Egypt along the Nile? Or are you going to start in Egypt and go all the way to Ethiopia, the big lake out there, with the maximum lookout points? Where do you start? Minimum numbers. So you want to hit all of them early so you're awake. So here, 3 and 3. So you can even add them up to check. This is going to be much bigger than this. So this is not how you're going to go. You decided you want to hit them early in your journey. There you go. So then you put everything together and you number it. So 2 and 7 is bromo. This is going to be where 1, 2, 3, 4, and it's hinging onto this on the second carbon. So it's a secondary sec-butyl. So this is sec-butyl. Now sec-butyl, you go alphabetize with the B. So then bromo is Br, this is Bu, so bromo would be before the butyl. So we will go 2,7-dibromo. Always a dash between the word and the number. Then you would do the sec-butyl, Bu, sec-butyl. Again, hyphen between the end, second, third. And then you will say 6-chloro. And then you would do the methyls, 3,3-dimethyl. So a line, 3,3-dimethyl, I'm writing it here. And That's it. We mentioned all of the kids hanging on to those parents, and that's an octane. Octane. There you go. So lowest possible numbers to the other groups if the first group is the same. So let's look at this over here. We're going to look at this long chain here. So we have a long chain with an isobutyl and a third butyl. Am I right? Look at it and tell me what's the longest chain. Where are you going to start and where will you end to get the most number of branching? Maximum branching. Pause the video and number it and then start it again. All right. So the best way to do this is to go from the ends to a junction and see which one has longer and more substituents. So here's a junction and here's a junction. You can get them here or here. If you go this way, no substituents. If I go this way, I'm hitting 2 substituents. So obviously this is a better route. Scenic. And then here's a junction. This is only 2, whereas this is 3 and this is 3. So obviously this is not going to give me the longest chain. So it's not part of the parent. It's a kid. It's a branch. Over here, do the same thing. There are 2 ways to get to this junction. You can either go along this plain, boring route, or here you can see a couple of things. You can see this, 2 lookouts here. If I go this way, I'll only have 1. So choose the one which is more interesting. There you go. So that's how you get your parent. So always don't assume that parent chains are going to be written in a straight line. They're going to go kind of curvy all over the place. If they're going to be more exciting, then of course you want to have a lot more adventure on these rapids. Don't just go along the road because you'll fall asleep. Let's look at this. Where are you going to start numbering? That's the next thing. So here, the only possibilities are going from up to down, 1, 2, 3, or you can go 1, 2, 3, this direction. So which one do you think is the best to start numbering? They are both going to give you the same number of carbons because those are the 2 possibilities, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. Which one's best? Well, you have a maximum number of lookout points when you go this direction or this direction, but it says to hit them at the lowest number possible. So here you're hitting 2 methyls right here. Here you're only hitting 1 methyl. Then you would also have, well, every carbon has a substituent here. So that's the main reason. So you would go this way because you're hitting more substituents earlier on when you're wide awake. Good. So we already decided that's the best way to go. All right, let's say you didn't have branching here, then you would go this way because that's the first branching. First substituents count. So then write down everybody else hanging on here. Lots of ethyls here. 4 ethyl, 3 ethyl, 6 ethyl. So that's 3, 4, 6 triethyl. There's a triathlon going on here. Let's look at the others. Who else is on here? You got a branch here, 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 and here. So 7, and then 5, and then 2, and then 2. So that's going to be 2, 2, 5, 7, and that's 4 tetramethyl. So E before M, and then the parent is going to be octane. So octane. Let's look at the cyclo compound. It's got lots of hands and legs popping out. Let's see who's the parent. Well, for cycloalkanes, if the chain has more carbons in the ring, then the chain is the parent. If chain has the same number or less than the ring, then the ring is the parent. So you name it as cyclo, and then the number of carbons in the ring, ane, cyclohexane, because this is a 6-membered ring. Well, next thing, number from the substituent with highest alphabetic priority. Let's look at this. This is going to be meth, this is eth, this is sec-butyl, so that's B, and this is isopropyl. Isopropyl is I. So then we have to see which one has the highest priority. That's going to be number 1. No doubt about that. So because we have to start somewhere. Then we go next, assign lowest number to other substituents. So if we go down this way, we're going to catch a lot more of them earlier on. Then you write down your name. Then you write them according to alphabetic priority. So you mention this first, then F, then I, then M. So then 1 sec-butyl, or you can just put sec-butyl. You don't have to put the 1. Then you're going to name 3 ethyl, and then 5 isopropyl, and 2 methyl. And then you are going to put your parent name, which is cyclohex, not hex. And the functional group is ane. It's ane. There you go. So cyclo compounds are a little bit different from naming long chain. Alphabetic priority is really important. Well, what's this? They are kind of a geometric isomer, so you can have isomers if they're both on the same side, they're cis, opposite side, trans. You would have to mention them if they are given wedges and dashes. If they're both the same, let's say both wedge or both dash, that's a cis. One is a wedge, one is a dash, that's a trans. So again, same thing, this is an ethyl, this is a third butyl, so you have to number with the B. So then first you mention what it is. They're both opposite sides, so that's going to be trans. And then because this is a letter, you have to put a hyphen, then you put the name 1-butyl. And then you have to put third butyl. You can also put p-butyl. Then 2-ethyl. And then cyclohexane. Just to let you know that you have to sometimes show stereochemistry and then write it down in a way that you can convey it to somebody else. All right, then we got so many rules here, we got to apply some more, right? So we'll come back and do some more problems, go to the end of the chapter and practice all those namings. They got some really good problems out there. Brief summary here. The most important rule for naming an alkane is finding the longest chain with the maximum branches. That's like key, way on top of any other rule. You have to find the longest chain, and the longest chain has to have the maximum number of branches. Then you start numbering the branch from one of the ends to give the first substituent the lowest number. Then after that, we want to make sure the other substituents have the lowest number possible, okay? And then cycloalkanes have a slightly different rule where you give number 1 to the group with the highest alphabetic priority and then give the lowest numbers to the rest, all right? So we'll come back and do more problems. See you next time. Bye.